Hello everyone, this is the second introductory video on communication systems. In the previous video, we have seen some of the basic terminologies and the basic block diagram of communication system. In this video, we will discuss about what is modulation, what is the need for modulation and the types of communication system. The important process used in communication system is modulation, which is literally means a change. So modulation means a change. Let us now look at an analogy to understand the need for modulation. Do you think that you can throw a piece of paper to a distance of 5 to 10 meters? It is impossible because the paper is of less weight. At the same time, if you enclose a stone inside the paper, it can reach a long distance when it is thrown. This is because of the stone's weight. Stone carries the paper along with it. Here we can compare the less weight paper to a low frequency message signal in the communication system. This weak signal cannot travel across a long distance without any loss. Hence, we will take the help of a high frequency signal. This high frequency signal, which is going to carry the low frequency information signal, is being called as a carrier signal. By means of superimposing the low frequency signal with the high frequency carrier signal, we can send the low frequency message signal with a high frequency carrier signal to a very longer distance. One of the popular communication systems where the process of modulation is applied is in radio communication. Most of us have radio in our house, right? The radio gets the signal from the base station. The frequency of human voice signal is from the range of 20 Hz to 20 kHz. These are very low frequency signals. It is impossible to transmit these low frequency signals directly due to certain drawbacks. Let us see what are all the problems involved in transmitting the low frequency signal directly. The first problem is the height of the antenna in any communication system for transmitting a signal. We need an antenna for effective transmission of the height of the antenna should be at least 1/4 of the signal wavelength. If we consider sending a low frequency of 15 kHz, the wavelength is 20 kilometers. Then 1/4 of the wavelength is 5. Thus, we need to design an antenna with a height of 5 kilometers in order to transmit a 15 Hz. So, it is a very impossible thing. The second problem is nothing but of interference. If there is more than one base stations in the city, then the signal with the same frequency get mixed up with each other and the reception quality completely degrades. The third problem is the poor reception as per the equation representing the energy of the electromagnetic wave. It is clear that the energy of low frequency signal is very low on traveling across a longer distance. They become very weak. Another problem is the effective power radiated by the antenna. Theoretically, the power radiated from a linear antenna of length L is proportional to L by lambda, the whole square. This shows that when we transmit a message signal of a longer wavelength, that is of low frequency, the power radiated will be of very small. The reason for all these problems is the low frequency, that is from 20 Hz to 20 kilohertz. If the frequency is high, we can overcome all these problems, but how we will increase the frequency of the message signal? Actually, we will not increase the frequency of the message signal, but we will superimpose the low frequency signal with the high frequency carrier signal, and then we will transmit it. Hence, the characteristics, that is the amplitude, frequency and phase of the carrier signal will be changed in accordance with the message signal. This process is called as modulation. I will repeat again back the definition of modulation. The characteristics of the carrier signal such as amplitude, frequency or phase of the carrier signal is changed in accordance with the message signal. This process is called as modulation. Let us now see the problem in the transmission of low frequency signal or overcome by modulation. To overcome the problem of antenna height, if a high frequency signal of 1 MHz is used, the height of the antenna will be around 75 meters, which can be achieved practically. To overcome the interference, if the station transmits a high frequency signal like 2 MHz and 6 MHz, then there is a difference between the two signals, and the difference will be, that is 4 MHz, and thus the wave will not mix with each other. Next is of the poor reception. To overcome this poor reception problem, if the frequency of the signal is high, automatically the energy of the signal will also be high. Hence, we can obtain a good quality signal at the receiving end by using a high frequency transmission. We can achieve high power radiation without changing the antenna height by means of modulation. The modulation helps us to replace the wired medium with wireless medium. Also, we can achieve a high range of communication by using modulation. So these are all some of the aspects why we go for modulation. So far, we have studied about the modulation and the need for modulation. When the modulated signal reaches the receiver, it is necessary to separate the message signal from the carrier signal. This process of recovering the low frequency message signal from the modulated signal is being called as demodulation. So, the modulated signal is being given to a demodulator in the receiver, and the demodulator, what it will do is it will separate the low frequency signal, that is the information signal, from the high frequency signal, and it is being given to an amplifier, after which we will receive a good quality of reception at the receiver side. Now let us solve a problem based on height of the antenna. Find out the height of the antenna required to transmit a voice signal of frequency 3 kHz. We know that for the effective transmission, the height of the antenna should be equal to lambda by 4. We can obtain the wavelength from this equation, C by F. So the wavelength is of 100 kilometers, from which the height of the antenna is of lambda by 4, that is 100 by 4 is of 25 kilometers. Let us now discuss about the types of modulation. The modulations is broadly divided or classified into two types: analog modulation and digital modulation. If the message signal is analog, then it is known as analog modulation, and similarly, if the message signal is in digital form or in terms of ones and zeros, then it is known as the digital. First of all, let us talk about the analog modulation. Based on the types of the carrier signal, this analog modulation can be further classified into two categories, that is continuous wave modulation and pulse modulation. So, if the carrier signal is continuous wave signal like a sine signal, then it is known as continuous wave modulation. On the other hand, if the carrier signal is a pulse signal, then it is being called as digital modulation. Let us further classify the continuous wave modulation. The continuous wave modulation can be classified into three types, that is amplitude modulation, frequency modulation and phase modulation. Amplitude modulation. So, in the case of amplitude modulation, the amplitude of the carrier wave is being changed in according to the message signal. If this is the message signal and the high frequency signal is the carrier signal, then the amplitude modulated wave will look like this. So, as you can see over here, the shape of the carrier wave changes according to the message signal. Similarly, in the case of frequency modulation, the frequency of the carrier wave changes according to the message signal. So, with the increase in the amplitude of the message signal, the frequency of the modulated signal also increases. Similarly, with the reduction in the amplitude of the message signal, the frequency of the modulated signal will also is being reduced in the frequency modulation. Similarly, in the phase modulation, the phase of the modulated signal changes according to the message signal. So, in the upcoming videos, we will talk about all these different modulation techniques in the detail. Let us discuss about the amplitude modulation in detail in the upcoming video. Thank you all.